Today we're looking at trig identities. They would be angle addition identities and double angle identities. Dylan had a question on this and I was sure everyone could use this help also. So I have some information listed here, and then we're going to try a couple examples of problems that Khan Academy was having you do in the exercises. I just want you to know ahead of time, if we were together in class, we would do it the harder way, but the more understandable way for later in AP Calculus. When I look at the problems on Khan, I can see the best thing for us to do at this point in our lives is the easiest way. So we'll talk about that. So first of all, over here, I just want you to understand this is what I would have taught you and more when we were in class. And I actually have you memorize all these things because you need them for AP Calculus. You won't have to do that this year. But I also just want to quickly then get some good understanding for you that it's actually not as complicated as it looks when we're in the class together. So basically, a trig identity are truths, things that are true. And so what they're saying here, I actually have two different problems. If you have sine of one angle plus, well, we're going to ignore the minus for a moment. Sine of one angle plus another angle. It is really tempting, if you had to make a guess of what that would be equal to say that might be sine of A plus sine of B, and it's not. We'll talk about that. Sine of one angle minus another, right, again would be tempting to say that that's sine of A minus sine of B. And we show you in class, you tell me that that's absolutely not true. So there is a formula that is true. And what it is first angle is A, second angle is B. And what sine of A plus B is equal to is sine of A times cosine of B. Because it's sine, the sine stays the same, plus cosine of A times sine of B. Now when I have you memorize it, it's actually pretty easy because the sine stays the same here. Notice that the A and the B always stay in order. Just wanted to point that out to you. What about cosine A plus B? Right? That would be tempting to think, if you look down here where I'm pointing, that cosine of one angle plus another might be equal to cosine of A plus cosine of B. Not true, and it's easy to show that that is not true. So we do have a formula for what is true, and the way I remember cosine of A plus B is that cosine is like co-workers, they go together. So cosine of A, cosine of B go together. Because it's not sine, the sign changes. And then you have sine of A, sine of B. Again, notice that the angles AB always stay in order. So I just want you to know, even though it looks confusing, we would have had a great ways to look at it in class. It's tempting to think that sine of a double angle, so if you had an angle A and you doubled it, it's tempting to think, when you look down here, that that might equal 2 times sine of the angle. It's not true and really easy to prove. So here's a formula for it. It is 2 times sine of the angle times cosine of the angle. Cosine of a double angle is equal to cosine squared of the angle minus sine squared, whoops, of the angle. And there's two others. There's two other little formulas. I just want you to see, I keep saying why these are not true. Let's look down here. Now what I want to show you is, remember on the unit circle that cosine is the x value. Okay, so take a look. I made an angle A here in red, and I drew a red line. That is cosine of A. Okay, now I drew a bigger angle B in blue, and notice that in blue here, I drew the side of x for that angle, and that is cosine of B in blue right here. Well, take a look here. If I add angle A and angle B, I get a larger angle, right? This green angle here, A plus B. Well, take a look at the cosine of that. This green line right here. Obviously, when you add cosine of A plus cosine of B, you're not going to get cosine of A plus B. That's actually smaller. So this is not true, and this is why we have formulas. Okay, now let's come on over to one of the first problems. Now, if we were in class together, here's what we would have done. So on Con, they're asking you to find cosine of pi over 12. That is obviously a radian measure, and they want the cosine of that. And they provide these possible answers for you here. And I can see where I'm just making these different. We need to make changes. I did this super early while I was drinking my coffee. So apparently I needed more coffee. Okay, and they offer these answers here. Now, if we were in class, and the way Con probably teaches it, is what I would have had you do is cosine of pi over 12. I know that's 15 degrees. You would have known that too if we were in class together. And what they would have wanted you to do is actually write pi over 12, because this value isn't on the unit circle, right? Our smallest angles are 30 degrees, not 15. They would have wanted you to write pi over 12 as two angles being subtracted that are on the unit circle. If you took the time, pi over 3 minus pi over 4, if you got a common denominator, you would have had 4 pi over 12 minus 3 pi over 12. You would have had pi over 12, okay? We would have worked that out in class, right? That is really hard for you to do at home, okay? What would I have had you do from here? Cosine of two angles being subtracted. I would have had you come over here to this formula, cosine of two angles being subtracted, and I would have had you write cosine of A, cosine of B, plus sine of A, sine of B, just like I wrote right here. Okay, this is what we would have done in class. What would we have done from there? All of these values that you see here are on the unit circle, and we would have filled them in and did a little bit of math, okay? Because it is very doubtful for when you're at home for you to be able to come up with that on your own. I have an easier way for you to do it. So let's come on down here. What should you do then? What's the easiest way to do this problem? So first of all, here's what we're gonna do. We're gonna make sure we're in radian mode. Since they gave us radians, let me check my mode. I am in radians. I am simply gonna type in cosine of pi over 12, right? I'm gonna use my calculator to do this. Cosine, and then pi is right above the little caret button there. There's pi in blue. Pi divided by 12. There we go. I'm gonna write that decimal to the third place, 0.966. That is cosine of pi over 12, okay? However, here are the answers that are provided on Khan Academy. So what do? How do I know which one of these matches 0.966? Because that's the answer. Simple enough. I'm going to put each one of these into the calculator and turn it into a decimal. So here's the square root of 2. I'm working on the first one. Minus the square root of 6. I am going to divide that by 4. And let's see, that is a negative. I guess I should have known that ahead of time, that this was going to be negative and not right? So this is, I'm just going to put that's a negative answer. I shouldn't have even bothered with that one. The answer is positive. Let's take a look. Let's try the square root of 3 minus 1 over 2. Square root of 3 minus 1 divided by 2. I know it seems silly, but you really have to be careful how you put that into the calculator. That is 0.366. That does not match my answer. How about 1 plus the square root of 3 over 2? There we go. Oh, that's a little too big. That's so funny. Maybe I need more coffee. Class, look at this. Didn't we know kind of that was going to be too big? Bigger than that. I should have known. Anyway, so it would appear this answer is the last is correct. The square root of 6 plus the square root of 2 divided by 4. That is 0.966. That is how I know on Khan Academy that that is the correct answer. That's the easiest way to go. So again, just simply make sure you're in radian mode, type in cosine of pi over 12. If they are providing you answers, turn them into decimals and match them. Okay, let's come on over here to number 2. They wanted you to find sine of 2 times the angle BAC. There we go. In other words, they're asking you for sine of a double angle over here. Now, if we were in class together, what does con and what would your textbook and what would I want you to do, because it helps later in AP Calculus, not to make your life difficult? I would have used sine of a double angle formula. I would have come on over here, right here, and I would have said, oh, that's 2 times sine of the angle times cosine of the angle. Okay, that's what I would have done. What should you do? Since you're at home and you're using con, what's the easiest? The first thing we're gonna do is to answer this question right here. Let's find the angle BAC. Okay, and since you're asking your calculator for an angle, it's best to be in degree mode rather than radian. You just understand it better. So degree mode's a little bit better. I'm gonna take a second to do that. There we go, I'm now in degree mode. All right, so when you've been given sides of a right triangle, how do you find the angle? If you remember, that's inverse. And there's a couple things you could do here. Notice that this angle BAC that I've circled here, notice that its sine is 4/5, opposite over hypotenuse. So I could do, whoopsie daisy, inverse sine of 4/5. Notice also, some people could say, well, I do see that cosine is adjacent over hypotenuse is 3/5. I could do inverse cosine of 3/5 on my calculator. Either way is just fine, right? So I'm going to do not sine, I have sine, it's 4/5. I'm going to do inverse sine on my calculator of 4/5, and that is 53.1 degrees. Right? Just because you're stuck with me on this video, what if we did inverse cosine of 3/5? Inverse cosine of 3 divided by 5, I get the same angle measure, of course, because I should. So what do I do now? I simply go, okay, angle BAC is 53.1, and I am just going to put this in the calculator in degree mode, right? And I'm gonna just type it in like I see it. Sine of 2 times 53.1, and that answer is 0.961. Now, if con is asking you to type in the answer, there you go, you can just type it in. What if it's multiple choice and they ask you, your answers look something like these over here? Again, just turn their answers into a decimal, find the one that matches yours. Last, we're not going to go over this problem, but again, I just felt just talking about it would help you. How would you do cosine of angle ABC minus 60 degrees using the same triangle? All right, I'm going to do that in red. Let's look at angle ABC. ABC is in red right here. Again, all you would do is actually get this angle ABC in degree mode, easier to read, by using inverse cosine or inverse sine, just like you did. And then just put that angle measure right here and simply type in cosine of your angle measure minus 60 degrees, and your calculator will give you that decimal. And I hope this helps, Dylan and anyone else. And if you have any more questions, or a particular one, just stamp a picture of it and send it to me. But I hope this helps with trig identities, with additions and double angles. Thanks, and have a great day.